Welcome to this video. I am Julio and I will be explaining Unit 2 of Topic 3, which is Data Transmission in Networks, from the Computer Science IB curriculum. This unit consists of 5 different topics: protocols, data packets, and data transmission, why are protocols necessary, speed of data transmission and why can it vary, what is compression of data, and different transmission media and its characteristics. So first of all, what are protocols? They are a set of rules or guidelines that determine how data is transmitted and received over a network. It ensures that devices can communicate with each other in a standardized way. Common examples include TCP, IP for the internet communication, HTTP for web browsing, and FTP for file transfers. Protocols are important for 4 main reasons. First of all, they ensure data integrity. This refers to making sure that the data transmitted is not altered or corrupted during the transit. Protocols like TCP use checksums or hashes to verify that the data received is identical to what was sent. If any changes are detected, the protocol triggers a retransmission of the corrupted packet, ensuring the data arrives intact. Then, they are also used to manage flow control. This ensures that data is sent at a rate that the receiving device or node can handle, preventing it from being overwhelmed. For example, TCP uses a mechanism where the receiver informs the sender about how much data it can accept. This is often called the sliding window mechanism. Without flow control, the receiver might be flooded with too much data and could drop packets leading to data loss. In third place, they are also used to manage congestion. Congestion occurs when there is more data trying to travel through the network than it can handle, leading to delays, packet loss, and overall poor performance. Protocols like TCP implement congestion control mechanisms, such as slow start and congestion avoidance, where the sender adjusts its transmission rate based on the feedback about network conditions. This helps avoid overwhelming the network with too much data at once. Congestion basically works in the same way as traffic. Finally, protocols are also used to perform error checking. This ensures that data transmitted to the network is correct and has not been corrupted. Protocols like TCP and UDP include mechanisms for checking errors during transmissions. Checksums and cyclic redundancy checks are commonly used methods where the sender computes a value based on data and the receiver verifies it. If the values don't match, the packet is considered corrupted and the receiver can request a retransmission. All of these functions work together to ensure that network communication is reliable, efficient, and free from disruptions, making the internet and other networks function smoothly. Next, it's important to know what a data packet is. It is a small unit of data that's bundled for transmission over a network. It typically includes the data being sent along with control information like the source and the destination addresses, error checking details, and sequencing information to ensure the data is reassembled correctly at the destination. Now let's talk about the transmission process of the data. When data is sent between nodes, devices on the network like computers or routers, it's broken into smaller packets. These packets move through the network, hopping from node to node. Each node reads the packet's destination address and forwards it to the next node or destination device. At the final destination, the packets are reassembled into the complete message. This process is often handled by network layers like the OSAI model, with each layer performing specific tasks for routing, error checking, and ensuring data integrity. The speed of data transmission across a network can vary due to a combination of factors that affect how the data travels and is processed. Here's a brief look at how each of the factors you mentioned can influence the network speed. First of all, traffic. Network traffic refers to the amount of data being sent across the network at any given time. High traffic levels can cause congestion, where too much data is competing for the same resources, which slows down transmission speeds. For example, when many users are accessing a website simultaneously, the network may become congestion, causing delays. Next is time of the day, which can have a significant impact on the network speed due to varying levels of traffic. During peak hours, like evenings when many people are online, there tends to be more demanding on the network, which can lead to congestion and slower speeds. Conversely, off-peak hours usually experience less traffic, resulting in faster speeds as the network is less congested. Next, we have to talk about the distance. Distance between the source and destination of the data affects transmission speed, especially in the case of latency. Longer distances typically mean higher latency because it takes time for the data to travel across the network, especially when crossing multiple routers, switches, or even undersea cables. This delay can make the transmission feel slower, even if the bandwidth is high. Finally, there's infrastructure. The network infrastructure, like the cables, routers, switches, and modems, plays a crucial role in determining how fast data can move. Old or inefficient hardware can act as a bottleneck, slowing down the connection. For example, an old copper wire connection can have slower speeds compared to modern fiber optic cables, which provide much higher bandwidth and lower latency. The next topic is compression. Computer science compression refers to the process of reducing the size of data files or streams, making them easier and faster to store or transmit. This reduction is achieved by removing redundancy or using algorithms that represent the data more efficiently. Compression can be applied to a variety of data types, including text, images, video, and audio. The necessity of compression comes from several reasons when transmitting data across a network. These are they reduce the bandwidth usage because compressed data takes up less space, meaning less bandwidth is needed for transmissions. This is especially important in networks with limited bandwidth or during periods of high traffic. Secondly, it improves speed. Smaller data files are quicker to transmit, reducing latency and speeding up the overall transfer process. Lastly, it minimizes costs. Since less data is being transmitted, it can reduce data transfer costs, particularly from mobile networks or cloud services where data usage is built. There are two main types of compression: lossless and lossy compression. Lossless compression is when the data is compressed without losing any information. The original data can be perfectly reconstructed after decompression. Some examples are, for example, zip files or PNG images. This is ideal for text files, executable files, or any data where loss of information would be unacceptable, like, for example, a document. On the other hand, lossy compression is some data that is permanently discarded to reduce the file size further. This can result in a loss of quality, but the compressed file is much smaller, therefore much easier to transmit. An example would be, for example, an MP3 audio or a JPG image. This is suitable for medial files like images, audio, and video, where a small loss in quality is acceptable in exchange for significant size reduction. In summary, lossless compression retains all original data, ensuring perfect reproduction, but with moderate size reduction. And lossy compression is way more efficient, but it sacrifices some data to achieve a greater compression. It is only used when loss of quality is acceptable. The next topic is transmission media, and first we will talk about wired transmission media. This refers to the physical cables and wires that carry data signals between devices. There are three main types. First of all, twisted pair cable. Twisted pair cables consists of a pair of insulated copper wires twisted together. These wires carry electrical signals between devices. The twisting reduces electromagnetic interference from external sources. It is used in telephone systems or Ethernet networks. It offers moderate speeds and can be used for short to medium distances. Then there's the coaxial cable. It has a central conductor, usually of copper, surrounded by an insulating layer, a metallic shield to protect against interference, and an outer insulating layer. The signal travels through the central conductor. It is used for cable television, internet connections, and some network connections. It offers high speeds, up to 10 gigabits, and it can cover medium to long distances with better resistances to interference compared to twisted pair cables. The third type of cable is fiber optic cable. It uses fiber optic cables, use strands of glass or plastic to transmit data as light signals. The data travels through the core by bouncing off the inner walls, which ensures minimal signal loss and high speed. It is used for high-speed internet and long-distance communication, and it provides the highest speeds, up to 100 gigabits per second, and can transmit data over very long distances, like tens to hundreds of kilometers, with very low latency. Finally, let's talk about wireless transmission media, which refers to the transfer of data without the use of physical cables, typically using electromagnetic waves. The first type is with radio waves. Radio waves are used for short and long range communication by transmitting data through the air via electromagnetic waves. Devices like radios, cell phones, Wi-Fi routers, and Bluetooth use radio waves. It is used in wireless networking, mobile communication, radio broadcasting, and satellite communication. And the speed can vary greatly depending on frequency and technology used. It can go between 1 and 10 gigabits per second. Next, there's microwaves. These use high-frequency radio waves to transmit data. Microwaves communication typically involves line-of-sight transmission between ground stations or satellites. It is used in point-to-point communication links, satellite communications, and some internet backbones. It can offer high-speed transmission, hundreds of megabits per second to gigabits per second, but requires clear line of sight and can be affected by weather conditions. Last but not least, there's infrared. Infrared waves are used for short-range communication. These waves transmit data by modulating infrared light, which can be detected by sensors in devices. It is used in remote controls and it is only used in very short-range data transfer, like some wireless peripherals. It typically offers very low speeds, like 4 megabits per second, and very short ranges, but it is ideal for personal area networks. So this is the whole second unit of the third topic of computer science IB curriculum, and thank you very much for listening the whole time.